Shortcuts are great, but they're also limiting because they usually only work in specific situations. Okay? So in integration by parts, if the U choice is a polynomial, then tabular integration works. But the U choice has to be, you have to be at P. In other words, you can't, this does not work on any L or I. It does not work on any logs. It does not work on any inverse trigs. It only works if the U choice is a polynomial. So that's the limitation. It's great. Integration by parts is fantastic, but it is limiting in what it works on. Okay, so again, to give you that caveat that it only works if U is a polynomial of some kind. All right, so let's start with an easy one. We did it yesterday, and I'm just going to show you how it would work this way. Okay, we started yesterday with x sine x. That was our first example, I believe. Let me double check my notes. Yes. Okay, so I showed you how to do that with parts. The U choice is x, because in Lipit, polynomial beats trig. Okay, tabular integration comes from the word table, and we set it up like a table. Okay, so you have your U choice, and you have your dv. All right, U is chosen to be x, dv is chosen to be sine x dx. Then you extend the table in a vertical direction. You're going to go down. The U column is going to go down in derivatives. So we go from, okay. So we go down. The derivative of x is what? 1. Okay, again, the derivative of 1 is 0. Okay. The dv column is going to go up in antiderivatives. So the antiderivative of sine x is negative cosine of x. The antiderivative of negative cosine of x is negative sine of x. Okay? All right, now you pair up diagonally those two pair, and these two pair. And the answer to the problem becomes the yellow pair, which is negative x cos x, minus, because integration by parts is based on uv minus the next term, minus the green pair, which becomes plus sine x, and then plus c, and you're done.
Wait, what is that?
Well, because I'm minusing the green pair, and the green pair is already negative.
Oh, so you have to minus.
Okay, so I'm going to put a minus sign. It's yellow pair minus green pair.
So what if you have like multiple, like you have like x squared, and it becomes 2x and 2 is 0. Is that next?
Yes.
Great.
Okay. All right, so that is the same answer we got yesterday. It's just using a small table. All right, so here's one that's a little longer. So the integral of x to the 4th and e to the 3x dx. Because our U choice is a polynomial, then we can do tabular integration. So U and dv. Okay, so my U choice is going to be x to the 4th. Then I work my way down the table. So after x to the fourth would become 4x to the third. After that would become 12x to the second. 24x. 24. And you stop when you get to 0. So we're working our way down derivatives. The integral column of the table is going to start with e to the 3x. And we do the antiderivative, working our way that direction. So the antiderivative of e to the 3x is what? That's the derivative of it.
Well, e to the 3 is divided by 3.
Okay, so 1/3 e to the 3x. And the antiderivative of that? 1/9 e to the 3x. And the antiderivative of that? 1/27 e to the 3x. And then 1/81 e to the 3x. And then finally 1/243 e to the 3x. Okay. Then we start pairs. Okay, I'm going to start yellow and green. And we'll get some other colors in here. How about blue? And then maybe pink. And maybe, what else could we do? Orange? Okay, orange. Alright, so we start with the yellow, we subtract green. But the signs then from there on, now that we have multiple, are going to switch every other. So we only subtract every other one. So I'm going to subtract the green one, and I'm going to subtract the pink one. Why is that? Because when you do lots of integration by parts, it starts out with the positive combination minus the integral. Behind that, we would do it again, and then we would have a positive combination minus an integral. So then you've got a stacked double negative. Behind that again, you'd have a positive combination minus an integral. So it's the accumulation of the subtractions becomes one positive, one negative, one positive, one negative, one positive, one negative, in terms of the subtractions. All right, so then our answer is going to be the yellow pair, which is 1/3 of x to the 4th e to the 3x, minus the green pair, so 4/9 x to the 3rd e to the 3x, plus the blue pair, 12/27 x squared e to the 3x, minus the pink pair, 24/81 x e to the 3x, plus the orange pair, plus 243 e to the 3x, plus c at the very end. It will be very helpful to me and anyone grading your work if you do factor this and take out what they all have in common. So, what do they clearly all have in common? Okay, they have e to the 3x, and even more helpful would be if you could take a 1/3 out of that, because that will just clean this up quite a bit for someone looking at this visually. And so that would leave me with x to the 4th minus 4/3 x cubed plus 12/9 x squared, which 12/9 can reduce, minus 24/27 x, which also can reduce, plus 24/81, which also can reduce, and then still plus c is outside of the equal sign. So you'll want to reduce your fractions if possible. And so 12/9 becomes 4/3. 24/27 becomes 8/9. And 24/81, let's see, that becomes 8/27. maybe one more, and then I think that's enough. Okay, so how you feeling about that?
Great.
It's better than doing integration by parts 5 times. Yes, because then eventually we're going to say, okay, so now you got to solve it. So you want it factored. Okay. All right, last one. So let's do an integral of x cubed and then the sine of 2x dx. All right, so again, this only works if your u choice is a polynomial. So our u choice would be the polynomial x cubed, which is going to take us a couple rounds to descend. So it's going to take us down to 3x squared, down to 6x, down to 6, down to 0. Our dv then would be the sine of 2x dx. So these antiderivatives here will also be involving the anti-chain rule, so for fractions. So we'll have negative 1/2 cos 2x, followed by negative 1/4 sine 2x, followed by positive 1/8 cos 2x, ending with positive 1/16 sine 2x. And you would check your work by doing the derivatives the opposite direction and making sure you got back down. Okay, so these combinations here, make sure you know which ones are going to be positive and which ones are going to be negative. So if I'm color coding mine, my subtracted ones will be combination 2 and combination 4. The second and the fourth combination will be subtraction. But I still have to watch my other signs. So what happens when you combine the first two? Do you have a positive or a negative term? Negative. So it should be negative 1/2 x to the third cos 2x. Now the next two, the green combination, even though it's a subtraction, there's already a negative there, so that one ends up as positive 3/4 x squared sine 2x. The next one's also positive 3/4 x cos 2x. And the last one is 3/8 sine 2x with a plus c. Okay, now when you want to factor this, there is not anything that is common all the way through. And what? Well, a constant, but yeah, I could take a half out of everything. But you would want to group them by trig. Okay, so look to see what you could take out in common of the cosine terms. So in terms of the cosine terms, I could take a negative 1/2 x out of the cosine terms. That would leave me with x squared plus 3/2 when I factor just the cosine terms out. And then do the same thing with the sine terms and identify what you could take out of there. It looks to me like I could take a 3/4 out of that. So I could take 3/4 sine 2x. That would leave me with x squared minus 1/2. And then plus c. So that's the best way to write that answer, factoring out by the trig terms. So this is an alternate to integration by parts. It's great, but it only works in the one situation where a polynomial is equal to, where the u choice is equal to the polynomial.